So, welcome friends to this session of our discussion. In the previous class we are discussing about the optimal control of the discrete time system, and we have taken the case of a linear time varying system which, using the Hamiltonian approach, we develop the optimal control, and optimal control is nothing but my minus R inverse B prime lambda k plus 1, and once we are driving the u, we lead to the matrix difference Riccati equation, which is of the form as given here: p k equal to a prime k p k plus 1 I e k p k plus 1 inverse a k plus q k. So, this is my discrete Riccati equation, and equation is in the matrix form because P is our symmetric positive definite matrix, but the elements of the P is varying with the k. So, because we are considering the time varying system. So, it is a matrix differential Riccati equation. If P we will take inside this bracket, so we can alternatively we can write p k as a prime k p inverse k plus 1 plus e k inverse a k plus q k, and this difference equation we have to solve backwardly with the boundary condition as p k f equal to f of k f. If we will find out the u value is minus R inverse B prime inverse of the A transpose, which we are writing A to the power minus t. The meaning of this is inverse of the A transpose multiplied with p k minus q k into x k, where the R inverse B prime A inverse transpose p k minus q k we are defining as my L. L is nothing but I can say my controller gain, which I am using in my closed loop system as a k minus b k L k, because here L k x k is nothing but my u k. So, this is a k plus b k u k, u I will replace this. So, I will get the closed loop system equation as x star k plus 1 a k minus b k L k x star k. So, now my new system matrix will be a k minus b k L k. So, you properly designing the L k, I can have my optimal control. In this discussion, as we have discussed in the previous class also, to find out the value of the u k or L k, we need the inverse transpose of the matrix A. So, for that matrix A should be a non-singular matrix, otherwise the inverse of this matrix will not be possible. So, to avoid this inverse, we can think of the another form of the Riccati equation, which we will discuss today. So, as we have given my Riccati equation as a prime k p inverse k plus 1 plus b k R inverse k b prime k whole inverse a k plus. So, this is my discrete matrix Riccati equation. So, we take the matrix identity consider the matrix identity A1 inverse plus A2, A4, A3 inverse of the whole equal to A1 minus A1, A2, A3, A1, A2 plus A4 inverse, whole inverse, A3, A1. So, if you will consider the 4 matrix A1, A2, A3, A4, and we will find out the value of this identity, which is A1 inverse plus A2, A4, A3 inverse of the whole matrix. This is equal to A1 minus A1, A2, A3, A1, A2 plus A4 inverse of the whole A3, A1. So, in my Riccati equation, I consider this P1 matrix to be the A1, B I take as my A2, R inverse I take my A4, and B prime K I take my A3. So, this particular term, this can be expanded using this matrix identity. So, if I will expand this, what I will get? So, I will get the Pk which is A prime K. I expand this matrix using this identity. So, this is my A1 I am taking as Pk plus 1. So, this is the A1 inverse we are taking. So, I am writing this as the A1. A1 is nothing but my Pk plus 1 minus A1 A2. A1 is Pk plus 1, A2 is my Bk. Then I will have the matrix A3, A1, A2, A3, B prime K, A1, Pk plus 1. So, A3, A1, A2 is nothing but my Bk plus A4 inverse, A4 is my R inverse. So, this I can simply write as my R, and the inverse of this matrix, then A3, A1, A3, B prime K, A1, Pk plus 1. So, this is the expansion of this whole matrix, this inverse. This is multiplied with Ak plus, this is my Qk, Ak plus Qk. So, my this difference equation is converted into this form if I will use this identity. So, this equation I can write in this particular form, and let us say this is my equation 1. We will utilize this equation later on. We are given with U star K as minus R inverse B transpose lambda k plus 1. If I will take del h by del u equal to 0, then I will get the value of my optimal control as R inverse B prime lambda k plus 1. Lambda k equal to, and we have considered lambda k equal to p k x k. So, for this I can write minus R inverse B prime, in place of lambda k plus 1 I will have p k plus 1 x of k plus 1, and my given system is x k plus 1 as a k x k plus b k u k. So, x k plus 1 I will replace by a k x k plus b k u k. So, my u star k is nothing but minus R inverse B transpose p k plus 1, and for this I will have a k x k plus b k u k. So, now from this I will collect all the u k term at one side. So, I can write this as I plus R inverse B prime p k plus 1 b k, because this multiplied with b k u k I am taking on this side. So, this is I plus R inverse k b prime k p k plus 1 b k into u k, which is nothing but equal to my minus R inverse p prime k p k plus 1 a k x of k. Now, in this equation I am pre-multiplying with R k on this side, and I am also multiplying this with R k. So, with this pre-multiplication I can multiply this R k in this equation and this R k in this equation. So, what we will get? So, if I am multiplying this into, so I am getting R k, because R k is multiplied here, this R k will be the unity matrix R k plus B prime k p k plus 1 b k So, this is my left hand side R k B prime p k plus 1 b k, the whole multiplied with u k, and on this side I have minus R inverse will become unity here B prime k p k plus 1 a k x k. So, and naturally this u is my optimal control. So, I can write my u star k as just minus r k plus b prime k p k plus 1 b k whole inverse b prime k p k plus 1 a k, and this is my x k. So, now this whole I will can represent as my L k, and I can write this as nothing but my minus L a k x k. So, what actually we have done? We have determined the feedback loop. So, we are feeding back our state x of k multiplying with the L k to determine my optimal value of the u. So, this L a k is known as my Kalman gain matrix. So, as we have seen in the previous form of the Riccati equation, we will having the u in which we have to determine the L taking the inverse of the A transpose. So, in this case no A transpose is required. What we require, the inverse of the R k plus B prime k P k plus 1 B k inverse, and if we will analyze this term in L k, R k is a positive definite matrix which inverse is always possible. So, inverse of the R k exists, and this positive definite matrix is added with B prime k P k plus 1 B k. B prime k B k always gives a square term, and P k plus 1 is a again positive semi definite matrix, positive definite matrix having symmetric. So, P is the symmetric positive definite matrix, R is a positive definite matrix, may be symmetric. So, this means inverse of this term will always exist. So, in this case if this exists, so I can directly find out the value of L a k. As we have seen, this is my to determine the L a, I have to solve equation number 1 which is giving me the matrix difference Riccati equation. Now, this P k we can also represent in terms of the L a. So, if we will simplify this P k, so P k can also be represented as, so you can simplify this in the form it should be plus q k, the last term. So, if we will expand this term and write this particular term which will be coming out by the expansion of this bracket, we can say this is the R k plus B prime P k plus 1 B k B prime P k plus 1 A k. So, this is nothing but giving you the L a k. So, this Pk can alternatively be written in the form of La in by this equation. So, this will be my alternate form of matrix difference Riccati equation. So, normally we utilize this form to determine the value of the Pk and to find out the value of Uk, because in this case the carbon gain matrix which we are finding does not require the inverse of the A transpose matrix, and what the inverse exists in the LAK, we have shown that this inverse always exists, as my R is a positive definite matrix, Pk plus 1 is also a symmetric positive definite matrix. So, this inverse term always exists. So, by this we will have the two forms we have discussed. One can also develop the some another form of difference Riccati equation. So, in a time varying case we have one form of the matrix Riccati as Pk equal to A prime k P inverse k plus 1 Ek minus Ek the whole inverse Ak plus Qk, but by this our Uk require transpose of the inverse of the A transpose matrix. My second form is Pk equal to A prime k Pk plus 1 Ak minus Bk Lak plus Qk. In this case Lak does not require the inverse of the A transpose, and the inverse of matrix Rk plus B prime Pb, this inverse we have shown that always exists. Now, if we will consider the, so this was the time varying case. As my Kf will approaches to infinity, so as Kf will approaches to infinity, my Pk plus 1 is nothing but its previous value of Pk. This means we are starting evaluating the Pk. If this is my K from infinity, very large value, if I will say infinity. So, I am starting from this 0 value, and as Kf is infinity, my f of Tf, which is f of this is f of Kf, this is nothing but infinity, and this will be 0. This my P Kf is nothing but 0. So, we are starting evaluating the Pk from a 0 value, and in backward, and this solution after some time this will going to be a constant value. So, we can say that my Pk is equal to my Pk plus 1, or this is equivalent to some matrix P which is a constant matrix. So, if we will consider Kf as approaching to infinity and consider a time invariant case, this means matrix A and B both are the constant matrix, and my performance index says, because Kf is infinity, so there is no meaning of the terminal cost will be 0, and we have only half of summation k0 to infinity as x prime qx plus u prime ru, where q and r, q is positive definite, r is positive definite, but now these two matrix will also be the constant matrix. So, my A, B, Q, R are the constant matrix, my Pk and Pk plus 1 are equal to a constant matrix say P bar. So, my whole equation is converted, which was the difference equation before, because this term we will have the Pk plus 1. So, this Pk plus 1 and Pk both are same. So, this is converted into the algebraic equation, and this we call my discrete algebraic Riccati equation or simple algebraic Riccati equation for a discrete time system. So, we can write the P as A transpose P I plus Pb R inverse B prime P, by which we can also find out the U star as R inverse B prime A minus transpose P minus Q, which will be the value of the L. So, my Kalman Gale here becomes R inverse B prime A transpose P minus Q. Again in this case, as we have seen, we require the inverse of the A transpose. So, whatever be our alternate form which we have developed for the discrete system, in which there is no inversion of the matrix A is required, that can directly be converted into the steady state form. So, I stop my discussion here. Today in the next class we will see how we can solve a time varying matrix difference equation using the analytical approach. Thank you very much.